Contour analysis involves drawing isopleths on a map. An isopleth is a line of equal value, so every point along a specific isopleth is the same value. Now, there are several different types of isopleths that you'll often see in weather map analysis. Lines of equal pressure are called isobars. Lines of equal geopotential height are called isoheights or isohypses, or oftentimes just height contours. We'll talk about geopotential height a little bit more in detail when we get to upper air analysis. Lines of equal temperature are called isotherms. Lines of equal dew point are called isodrosotherms. Lines of equal wind speed are called isotachs. And lines of equal potential temperature, or theta for short, which is a thermodynamic variable that is related to atmospheric stability, are called isentropes. If you've ever heard of isentropic analysis, that is analysis that involves potential temperature. There are isopleths other than these listed here, but these are the main ones that you'll see in meteorological analysis. So for example, on this sample surface map, these solid lines you see here, those are isopleths, and on a surface map, we contour in isobars, lines of equal pressure. So for example, this isobar right here, this brown solid line you see right there, this is the 1004 millibar isobar. So that means that every point along this 1004 millibar isobar is 1004 millibars. Now, as a forecaster, how do you know exactly where to place the isopleths on a weather map? Well, there are a number of rules that you have to keep in mind when performing a contour analysis. Perhaps the most important of these rules is that every isopleth should have only higher values on one side and only lower values on the other. So say for example we have a field of values, say 81, 83, and 86. Well, if we try to draw the 82 isopleth and for some reason we put it through here, well, that's not going to work because we have higher values on both sides of that isopleth. In the same vein, isopleths should never cross or merge. So if you see isopleths making an X shape or a Y shape or a T shape, that is no good because that would mean that we have two different values at the same point where those isopleths come together. And of course, as we know, the definition of an isopleth is that all values along the isopleth are exactly the same. So that would violate that rule. So if you're doing an analysis and your isopleths cross or merge, you know you've done something wrong. Also, isopleths should never end within the data field. Even though we have a finite number of weather reporting stations, as you see on this sample surface map, every single point, down to infinitely small scales, has weather data associated with it. So just because we don't see a station reporting data, say for example in this void right here, doesn't mean there isn't any data there. The data field is continuous. And if we had an infinite number of weather reporting stations, we could capture data across all of the points in this domain. So because data is continuous, we cannot stop an isopleth in the middle of the domain. So if you're drawing an isopleth and you come to a point where there's really no more data to analyze, just bring the isopleth to the edge of the domain and call it good. And the final rule is that we need to label all of our isopleths. So once you've completed an isopleth on a map, let's say this is the 70-degree isotherm, you would label the isopleth at the edge of the domain and then maybe a couple points in the middle, just so you can keep track of which isopleth is which. This benefits you as the forecaster and those who are viewing your forecasts.
Don't learn storm chasing alone. Go where chasers are already talking. Discord community link in description.
Alright, let's do a very basic contour analysis using this data set here. Now, I have a couple tips for you before we start. If you're actually printing out a physical map to do an analysis on, always use pencil and have a good eraser handy. Contour analysis is an imperfect exercise, so you're going to make mistakes. So always use pencil and have an eraser handy so you can correct those mistakes for a more accurate analysis. And which isopleth you start with is up to you. Some people like to start with the lowest isopleth and work upward. Some people like to start with the highest isopleth on the map and work downward. I personally like to start somewhere in the middle and work out from there. For example, with our data set here, I see we have some 50s, I see we have some 60s, so I like to start with perhaps the 60 isopleth and work upward and downward from there. Let's start with the 60 isopleth. Now, exactly where you place the isopleth in between two data points is done through interpolation. So for example, with these first 2 points here, we have a 56 and a 64. Well, 60 is exactly halfway between those 2 points. So we place our 60 isopleth exactly halfway between those 2 points. Now continuing on, we have a 59 and a 62. 60 is a little bit closer to 59 than it is to 62. And we have to be mindful of the placement of the isopleth in between the initial 56 point and the 62 point. So we would bring that 60 isopleth a little bit closer to the 59 point. We then have a 59 and a 65. Of course, 60 much closer to 59 than 65. And then you see we have a point that's actually 60 right there at the top of the screen. So our isopleth is going to go exactly through that point. So we bring it up, go directly through that point. And then from there you see we have some 50s out here on the right side of the diagram and another 60 point down here as well. So we're going to have to get that 60 isopleth down here in between these 50 values and these 60 values that remain. So we'd bring our isopleth down. 60 is slightly closer to 57 than it is to 65, so we'd bring it kind of down just before halfway between those 2 points. And then we have a 57 and a 63. 60 is, again, exactly halfway between those 2 points, so we'd bring that 60 line over, right in between. And then we don't have any more data points out here, so we just bring our isopleth out here and kind of end it like that, just outside of the field of data. And then we would just label our isopleth. We'll label it at the endpoints, and then maybe a couple places in the middle, maybe right here, maybe one right there, and maybe one right there. And that is our first isopleth. So you can see it's pretty simple. It doesn't have to be exactly perfect. When you're doing a whole surface analysis, for example, you're going to be looking at a lot of different points. So you might not get it exactly halfway between 2 points if it's supposed to be exactly halfway between 2 points, or technically this 60 line may be just a little bit off from where it exactly should be if we were interpolating exactly correctly between the 59 and the 65 point. But overall, as long as you're pretty close and as long as you're taking a detailed look at the data, you should be good to go. And as you can see, we've kept our rules intact. Above the 60 isopleth, we have values that are only lower than 60. And below that line, we have values that are only higher than 60. Let's now draw in our 62 isopleth. Now we don't have a second point here along with this 64 point to start like we had for the 60 point, so we just use our 60 isopleth. So 62 is halfway between 60 and 64, so we draw that isopleth about halfway between 60 and 64. Then we have a 62 point right here, so we bring our line down, go right through that 62 point. We have our 60 isopleth and the 65 point right there. 62 slightly closer to 60, so we bring it up a little bit closer to the 60 line. Same thing as we go up toward that 60 point. Then we bring it back down once again. Our 60 isopleth dips downward like that, so should our 62 to keep that 62 isopleth between the 60 isopleth and the 65 point. So we bring it down. We have a 60 and a 63. That 62 is a little bit closer to 63 than it is to 60. And then again, we don't have any data that's left. So we just bring our isopleth toward the end of the field of data and then label it. And there you go. That is a couple of isopleths there. And you can see it's a fairly simple process. Now, when you have a lot of intricate data, like a surface map, it can get a little bit bunched up together. Now, just one more here. Let's do our 64 isopleth. We see that 64 point right there, so our isopleth would go right through there. And now notice there's not really any data that's left for us to interpolate where that 64 isopleth would go. So we would just kind of end it right here outside of our field of view. We can label that isopleth there. But you can see we have a 62 isopleth and a 65 point right there. So we can assume that our 64 isopleth will eventually curve up between those two things, but we don't have the actual data to prove that. So what we do is we'd end our 64 line there and then start a new one here just outside the domain. Let's start it, say, right in here. Then we'd bring it up between the 62 and 65. It would arc back down between the 62 isopleth and the 65. And then you see we have a 63 and a 65. So our 64 is going to go right in the middle of those two. And then we don't really have any additional data to continue the analysis. So we would end our 64 isopleth there, and that is that. And at the end, of course, we'd go back and do our, say, 58, 56 isopleths here, but in the sake of time, this should give you a good head start on the basics of contour analysis. Let's try another quick example. Let's start by drawing in our 48 isopleth. So our central value is 46, but notice how all of the other values are higher than that 48 value. So let's start drawing that isopleth in. So we'll start up here, 46 to 54, going to be a little bit closer to the 46. 48 is going to be a little bit closer to the 46 point. Then we go down 46 to 55, closer to the 46. And then 46 to 50, 48 is right in the middle of those two values. So we're going to dip down a little bit and then bring it back up. 46 to these 53 points, going to be much closer to the 46 points. So it's going to look something like that. And we have a closed isopleth. And this is acceptable. This is much different than if two different isopleths were to cross or merge. You can still have a closed isopleth, and every value along that closed isopleth will be the same. So this is acceptable, and in fact, you'll see it quite often on weather maps, particularly surface maps in close proximity to surface lows. So let's label this our 48 isopleth. Now let's draw in our 50 isopleth. So once again, all of those values are at or above 50, so we're going to have another closed isopleth. So let's start up here once again, 48 to 54. 50 is going to be a little bit closer to the 48 isopleth. Then we go out closer to 51 there. Between the 48 and the 55, going to be dipping back down closer to the 48. And then we have our 50 point right there. So our isopleth is going to go through that point. And then we just bring it back up like so. And we'll label that our 50 isopleth. So there you go. This is an example where we have closed isopleths, which is acceptable, and you will often see that in weather map analysis.
Remember to check out those links in the description below, and then watch another video.